This is actually not a quick video at all. It's a video, say you have a mathematically generated curve in space and you want to turn it into something that you can 3D print. It's called making a sweep, and I'm going to show you how to do that in Fusion 360 and in OpenSCAD. The idea is to create things like this. But I am going to go into detail with it. So what I'll try and do is put little markers down below so that you can skip to the relevant sections. For example, if you know how to do it in Fusion 360, you can just skip ahead to the part where I talk about OpenSCAD. But feel free to skip around. So what is a sweep? Say you have a curve in space like this. Here's a curve just floating in space. And say you want to fatten it up, you want to thicken it. So what you do is you sweep a cross-sectional profile along the curve, and you get something like this, a thickened version of the curve. So why would you want to do that? Well, maybe you want to print a spring like this. Threads on bolts and screws also can be made using sweeps. Or maybe more interestingly, you can subtract a sweep from a solid to create a complicated hole. In this case, you could think of this as maybe a thickened pipe, a thick-walled pipe with a spiral-shaped hole running through the wall. Maybe this would be used in a heat exchanger or a cooler or something like that. This is the kind of shape that would be very difficult to machine, but with 3D printing, it could be done relatively easily. So in this video, I'll show you how to create a sweep in Fusion 360. However, if the path intersects itself, this method fails in Fusion 360. So I'll show you a way to do it in OpenSCAD that avoids the self-intersection problem. So the first thing you want to do is generate a list of the points on your curve in CSV format. CSV format stands for comma-separated variables. So as a text file, it would look like this: number, comma, number, comma, number, new line, number, comma, number, comma, number, new line. And in our case, each line are the coordinates of a point. So you have the x-coordinate, the y-coordinate, the z-coordinate of point 1, x-coordinate, y-coordinate, z-coordinate of the next point, x-coordinate, y-coordinate, z-coordinate of the following point. So it's, since it's a curve in space, all the points have 3 coordinates. So it's a list of the coordinates of all the points on your curve. In order to generate this CSV file with all the coordinates of your points, in whatever language you're using, in whatever language you're using to generate the curve, you need to figure out how to output that data to a text file. In processing, which is the language I use, you need a create writer statement to name and open the text file, and then later you write to it using this, which you have the x coordinate followed by a comma, and then the y coordinate followed by the comma, and then the z coordinate all on one line. In whatever language you're using, you'll just have to look up how to write to a text file and find an example to figure out how to do it. You can do it in any language. It's worth mentioning that CSV files, with number, comma, number, comma, number, can be opened by spreadsheets, can be opened by Excel or LibreOffice Calc or whatever. And the spreadsheet will, if it's, number, comma, number, comma, number, on each line, it'll create 3 columns and fill the columns with the numbers. So once you have the CSV file with the points, open Fusion 360 and you go to Tools up here, and then you go to Add-ins here. You select Scripts and Add-ins. Then you go down and you find ImportSplineCSV. Click it. You click Run. And then you find your CSV file and you open it. And it seems like nothing happens, but you have to zoom out. There it is. The problem was we were zoomed in too closely. But there it is. That's how you import the curve. Next, you go to Solid, boom, and then Construct. You go along here, and you have Plane Along Path. You select the path, and select it near the end. And it should put a plane right at the end. And if it's not right at the end, this value here will be off. But make sure that value is 0. And that puts the plane right at the end of your path. And it's perpendicular to the path as well. Now what you want to do is create the profile of the cross section that you want to sweep along the curve. So in order to do that, you select the plane that you just created and then create sketch. If we go over here and we click on look at, it puts us staring right at it. So now we're in the sketch mode. We're creating a sketch. Let's just make the profile a circle just to keep it simple, but it can be any shape you want. So let's make a circle of 200 units, and we'll finish the sketch. Wow. So there you see the profile that we're going to sweep along the curve. Now we're ready to do the actual sweep. So we go to Create, go down to Sweep. It says Select Profile, so you're going to click on the disk that we just made. And then the next thing is select the path, which is this. And it thinks for a couple of seconds and creates the sweep. There it is. So here we have 2 curves rotating around in space. And you can see the curve on the left doesn't intersect itself. And the curve on the right does. It crosses itself. Now this causes problems in Fusion 360. So here's the curve that does not self-intersect. I imported it, and now we'll create the sweep. Select this, select the path, and it's fine. No problems at all, as we would expect. But here's the curve that does intersect itself. And so I try and do the same thing. Create, sweep, select the thing, and select the path. And I get this error down here. One error. The body would intersect itself. Try reducing the taper angle, removing areas of high curvature. It's a problem that I don't know why it's part of Fusion 360, but it just won't let you do that. It won't let you, even if you want to, you can't make a sweep intersect itself. So to get around that problem, I wrote a little sweep function in OpenSCAD. It's relatively straightforward. The first thing you need is this module that I call column that draws a cylinder between 2 points. So you give it the X, Y, and Z coordinates of 2 points and a diameter, and it draws a cylinder between those points. You can see from this code why some people don't like OpenSCAD. You have to do everything in terms of rotations and translations of basic objects. So here you needed a little bit of spherical coordinates, like from calculus class. If you like vectors, then maybe OpenSCAD is for you. If not, you probably won't like it. I'll include the code in the description anyway. But then the next thing you do is you run through your array of points and draw little cylinders between each adjacent point. Like here, if t is 0, you're drawing a little cylinder between point 0 and point 1. When t is 1, you're drawing a little cylinder between point 1 and point 2. You can, see this clearly if I skip points and just do every other point. You see that I've skipped every other section, and so you see the little cylinders clearly. So the only thing you need to know now is how to create the array with your points in it. A logical question would be, well, can you do that in OpenSCAD? Can you just fill the array in OpenSCAD? And you can't, at least not easily. It's just not suited for that. So we're going to have to find a way around it. But in any event, an array of points looks like this in OpenSCAD. It has outer brackets, and then because it's an array, but then each element of that array is a vector in square brackets itself. So you have a vector in square brackets, comma, vector in square brackets, comma, etc. Those are your points. So how do you fill that in with your points? So kind of in the same way we did before to create a CSV file, we, in whatever program we're using to generate the points, we output the data to a text file. Before we called it .csv. Here we can call it .txt. It doesn't really matter. It's not a CSV file. So, you create this file, spiral.txt, and then in your loop, instead of doing value, comma, value, comma, value, you actually need the brackets now. So you have to include the brackets. Brackets value, comma, value, comma, value, brackets, and then another comma. So you need to your output to your text file has to look like this, so you get a file that looks like this. And so now how do you get that into OpenSCAD? Well, what I do is just Control A, select it, Control C, go to OpenSCAD. Oh, here's your array. You have the first bracket and the opening bracket, the closing bracket. You just do paste it in, and the only thing you have to be careful of is that you have an extra comma there. Delete that extra comma, and then boom, it works. And you think, well, okay, that works for 100 points. What if I have a huge number of points? I've actually copied and pasted 4,000 points, just the exact same way. You select all, copy, paste, 4,000 points, and it worked fine. So, and the thing is, maybe there's a way to read those points into OpenSCAD and everything like that. But the fact is, using copy and paste, it takes like 2 seconds. The only thing you have to worry about is deleting that extra comma at the end. But that's it. It may not be the most elegant, but it works. And, the end result is it does what you want it to do. What are some issues with this method? Well, one is that it's maybe not the smoothest sweep. I noticed the sweeps in Fusion 360 are like perfect tubes. And here you're approximating a perfect tube with little sections of cylinders. You're approximating it. So it's not as perfect. But, the way around that is to use more points, so the cylinders are finer. One thing you may have to pay attention to here is that, on this side, the cylinders are a little too short and there are gaps there. But you can adjust that just by, over in your column module, just making the length a little bit longer. And it would depend on, like, the actual number you use would depend on your scale and everything like that, whatever would work for you. If I just add 2 here and run it, see it fills in the gaps. Fine. And that's probably fine if you're 3D printing something. Depending on the scale, you probably wouldn't see any gaps, or you wouldn't even notice that it's made up of little cylinders, because, especially if you're doing just plastic 3D printing, the resolution isn't that great, unless you're making something huge. Another little thing you might want to be aware of, in OpenSCAD, you have F5, which is preview. But in order to export it as an STL, for example, you need to render it, which is F6. And here you have, 100 little cylinders. And when you render something with a lot of, a lot of curviness to it, like cylinders and spheres and things, it takes a while. So it might take an hour. As I mentioned, this is the thing that I designed that had 4,000. If you look over here, it had 4,000 points, and it's a long story as to what it is. But when I render it, it takes like 2 hours. So you should be aware of that. And because you kind of think, oh, it's broken, it's, my computer is hung up or something, and you're tempted to cancel it or kill it, but it actually may take that long. And remember, also with cylinders and spheres, you have this parameter $FN, and if you change that, like if I change that to 4, the cross section is no longer a circle; it's actually a square. So you can mess with the cross section that way. Here you can have a hexagonal cross section. Maybe you like that. But if you increase it to say 50, the higher it goes, the more perfect a circle it is. But also the longer it takes to render. So